Okay, so in this demonstration, I want to illustrate the uses of the Garch model, specifically with respect to measuring the volatility of a time series dataset and also being able to forecast volatility in future time periods. Now, you will notice this uh, Excel spreadsheet is already populated. It's already populated with time series data, and in this case, it is based on the S&P 500 Spider ETF. I was able to get this data from Yahoo Finance. I'm sure you'll be able to do the same if you just Googled S&P 500 ETF Spider, Yahoo Finance, or some combination of those words. You'll be taken in very short order to the options where you could select daily returns, monthly returns, annual returns. And then once you've made your selection and you've also selected the time period or the sample period that you want to analyze, you can obviously then export the data directly into Excel. On that note, I actually want to show you one specific pointer before I move forward. So I've hit the File tab and I've just gone to Save As, and in my case it's Browse. So you'll notice that there are several options. There's several options under which you can save the exported data. Okay, I actually prefer if it was saved under the Excel macro enabled workbook. And the reasoning behind this is it will enable you to add the solver add-in under the data tab. Now I already have mine, but to show you how to get it if you don't have it, you go to File, Options, Add-ins, and you'll notice the My Solver add-in is under Active Application Add-ins. However, if the Solver add-in does not show up under your Data tab, it's more likely than not under the Inactive Application Add-ins. In that case, you would just highlight it, hit the Solver add-in, click the Go button, click OK, and then it should be under the Data tab, okay? With that said, I now want to take some time to briefly go over what I want to do in this demonstration, very briefly. So you see several equations here. Okay, this is the basis of the Garch model, where the variance is the dependent variable, and that in turn is described by several independent variables. And you'll notice that there are two versions of the same equation, the same model. Okay, in this case, you have long run variance, you have here you have variance from the previous time period, okay, and then in this case the U is the return, and you'll notice that gamma, alpha, and beta are simply weighted coefficients. So I will actually be working more closely with this model here, and in this case omega replaces the long run variance coefficient and term. Otherwise, everything else is the same, and it will actually be these coefficients here that I will be estimating using the maximum likelihood method that I'll introduce in other parts of the demonstration. Before I get there, however, I would have to calculate the return, the variance, and also calculate the volatility, because that's essentially what we're measuring, the volatility. But the volatility is a function of the variance. Once I've been able to estimate these coefficients, to estimate these weights, if you will, I will then be able to then forecast volatility into future time periods.